Okay, so let's look at definite integration. So just a reminder, integration is the opposite of differentiation or finding the derivative. So when we found the derivative of a function, we were able to find the slope. Now, integration is the opposite of that. And so instead of finding the instead of finding the slope, we're actually finding the area under a graph. The area under a graph. So integration would tell us the area. Now, so if we ever want to find the area of a function, then we can find the integral. So where would this be useful? Well, say that I had a velocity time graph in physics. I could then use the area under the graph to find our displacement. So if you haven't done physics, it's okay. You don't need to understand that, but it's just, the point is that it's handy. Okay. So, and practical. It's not just some abstract mathematical concept that you'll never use. We use integration and we use differentiation a lot in economics. So calculus is very, very handy and practical. It's a great branch of mathematics. So the first thing is the notation. So often you'll see this, this little weird S sound in that. If you see this in a question, that just means find the integral. Okay, so if we wanted to find the integral of that. So now the integral is the opposite of finding the derivative. So when we found the derivative, we took one of, we multiplied the exponent by the front, and we took one of the exponent. The integral, we're going to add one to the exponent. So let's just look at the rule. So what it might look like. So we could say k, and we could say, n is the exponent, right? And we could have a number in front of the exponent. Let's call that k. Now, if we wanted to find the integral of that, what we would do is we would add 1 to the n, right? So n plus 1, and then we would stick the k in. K wouldn't change, but we would then also divide by that n plus 1. Okay, now formulas are often confusing to look at. So let's just do a practical one. So let's say that we had x to the 4. We would then add 1 to the 4. So that would become then 5. And then we would divide by that 5. And then the k is just technically 1. So we leave it at that. And so it would just be a fifth. We could simplify that as a fifth x to the 5. So when you see x over 5, it's the same as a fifth x to the 5. So if your memo or the memorandum or the, you're doing examples and you see 1 over 5 or x over 5, these are both acceptable. But I think often we just leave it in the notation 1 over 5x to the 5. Okay, so that is the indefinite integral, right? When I say indefinite, because I haven't really assigned numbers, I've simply just given an equation for the integral. And let's now do our definite integral in, well, let's look at what the indefinite let's just discuss why it's indefinite and what that means. Well, I haven't assigned enough. So this is basically an equation, and if you just have a value, if you just have an equation but you don't have can't put in a number for x, you aren't really finding the definite integral, because it's not, you're not finding an area. It's like when I find the slope of a graph, so let's say the slope, which is the derivative, I can find the slope of a graph at any point. That's fine, and it basically, if there was a tangent to that point here, that I can find the slope at any point on a graph. So that is possible. But I can't find the area at any point, but the area at any point is undefined because you don't have 2 points. So you can't find the area of a line. Does that make sense? So slope, you can find the area at a point. I mean, you can find the slope at 1 point. So if I was to find the derivative of this, which is minus 2x, and this was, say, minus 2, I could then put in my minus 2, and minus 2 times minus 2 is 4, and the slope at 2 is 4, which you can see. So the gradient of this tangent at this line 4, at line at x equals minus 2 is 4. And if I found the slope at any point, if I just subbed in the x values at any point on this graph, I would be able to find the derivative. So that works. But finding the area at a point is impossible because we cannot find the area of a line. So if I was to say, oh, let me try and find the area at minus 2, well, that technically, if I was to put in minus 2 here, I would get an answer, but that isn't an area. And now we're going to explain why. Well, we've already explained why, because you can't find the area of a line. So like if I have a square, I can find an area, but as soon as I have a line doesn't have a height. So how am I going to find the area? I can't. Okay, so if I put in minus 2 here, I actually get an answer, so that doesn't make sense. So now the first thing that I can do is I can go back to the mathematics and say, well, something is missing from here, because why am I able to do it? And that something that's missing is called this plus c. Okay. Now, this plus c must always just be put on as a default. So even if you don't understand why, just put plus c on. You have to put plus c on. And let's look at this. Well, when I said the derivative is the opposite of the integral, notice that when I find the derivative of this function, and I got minus 2x, if I was to work backwards from that to get back to my original function, so let's say I wanted to get back to my original function. So let's went back from minus 2x to try and get to minus x squared plus 9. Well, remember, I add 1 to the exponent. I leave k as it is. I add 1 to the exponent. So this is to the exponent 1. I would add 1 and get 2. Then I would divide by that 2. And I would be left with negative x squared. Well, that's for this bit. But this plus 9, I cannot get to, because it could have been plus 10. I still would have got minus 2x as my derivative. So that's the first thing we know, is that this plus c is important. Okay, and because I don't know the plus c, I can't actually find a integral. I can't find the area. So now what I need to do is I need to solve the problem of when can I actually use this integral practically? Well, you can simply make it practical by doing what we call the definite integral and actually defining 2 points on that function where you'll find the area. And so, I could pick that minus 2, that would be fine. Okay, so let's do the indefinite integral in orange. And so we'll say definite integral. And let's define 2 points. And so we've already used -2, so why don't we just use -2? So the -2 would go up. That would be technically then sort of there, the area. And let's just use 3 because it's over here, and we know that it would get a nice thing. And so we can actually find this area here by simply taking the integral at -2 and subtracting by the integral at 3. And that would then give us an area. Okay. Now, just a point to note, I don't want to confuse you, but if I was to then make it to 4, do you notice that I've got it sort of crosses the x-axis? Well, at this point, what you do need to do, and this is just for the future, is you'll need to know that this 3, it crosses the x-axis. You'll have to find the integral between -2 and 3, like that. And you'd have to then add the integral between 3 and 4. You couldn't do the integral between -3 and 4 because of this crossing over. And you notice what we have here is an area above the line and one below. And so when you if you were to find the integral, what it would do, if you went from just -2 straight to 4, it would take this one below the line and it would subtract it from this one. It would give you like an area. It would take these 2 off, right? And it would just give you this area here. And that would be wrong because the total area is actually these 2 added together. Okay, so that's just something to bear in mind for the future. And another thing to know is that if I get an area and it's negative, it doesn't matter because our area cannot be negative. We just have to change it back to positive. So in other words, if I did the area and I put in -2 and then I subtracted from the integral when I put in 3 and I got a negative, it would just be the negative value of that would be the same number, but one would have a negative and one would have a positive. I'm going to do both just to show you. Okay, so the definite integral, we've already worked out no, we haven't. We haven't got the integral yet. So let's do that. So the definite integral, I'm going to say, then the notation would be between 3 and -2. And it doesn't matter which way I do this, as I say. What I can just simply do is, okay, well, let me do one first. So we'll do between -2 and 3. So the integral, we add 1 to the 2. Okay, so well, let's just do the question that it might be. So -x² plus 9 integral. So we say, okay, find the integral. So integral would be -x, add 1 to the 2 to become 3 and divide by that exponent of 3. The 9, technically, if there was an x to the 0 there, it would become x to the 1. So any number which is just doesn't have an x, we can simply just say 9x. We just pop an x on. So that's fairly simple. Don't worry too much about the maths. If you do x to the 0 and you add 1, fairly simple. And if you were to divide by 1, you would still get 9. So it's always going to work out. So this 9, just pop an x on, and then always remember to pop that c on as well, plus c. Okay, so now that I've got this, the integral, I've still got to then do the value between -2 and 3. So what I'm going to do is I'm just going to say, put a bracket, big square bracket there. I'm going to say -2 to 3. And that's telling me I need to take one away from the other. Okay, so the first thing I'm going to do is I'm going to do one with the -2. So I'll say it'll be negative, and then I'll put -2 in the brackets cubed over 3 plus 9 -2 plus c. Okay, so let's put a little round bracket there, minus, and then I'm going to put in the 3. So it's -3 cubed over 3 plus 9 to the 3 plus c. Okay, now I'm going to just use a highlighter to just show what I did there. I did go through that a bit fast. We'll use a light green. So I went between two. So this, remember, I got the integral. So this was just the, if this wasn't between two numbers, this bit here, if this wasn't between two numbers and was just regularly done, this would be the indefinite integral. But because I have defined numbers that I'm going to use to substitute for x, I put the -2 in on 1. And so you see, everywhere I saw an x, I put in a -2. Okay. Now, everywhere I put in, anywhere I have an x, I'll then put in a 3. And so it's the same function, but one is with -2, one is with 3. I'm simply just going to subtract them from each other. Now, what's the first thing? Well, it's not the first thing I noticed, but one of the things we notice, which I'm going to deal with initially, is just that you see these c's end up going away because of plus c and a minus c. So the c's are taken care of by this definite integral. So you see the c bit there always goes away, and that's handy. So if we want to just put these values in our calculator, well, -2 to the power of 3 is -8, and then -8 would be +8. So we have 8 over 3, and this would be -18. So let's put those values in. So 8 over 3 minus 18. And then here we would have minus, and then we would put in, Liam, do you want to put this in your calculator so long so we can get some values? So -27 over 3 for this one would give us -9 plus 27 equals -15 and a third, I believe. This is 9 and 18 plus 18. That's right. This is that would be -18. And so we would get -33 and a third. I don't know if you want to check that on your calculator. Now, what we notice is,
yeah, that's right.
What did you get?
Yeah.
Okay.
-33.333.
Okay. Now, let's say that we did it the other way round. We would have this here would be -18 minus so yeah, we would have, if we did it this way, we would have 18. Okay, so let's say that so this would be, now notice that I have a -33 and a third. Now, what I want to do is say, okay, so how would I avoid doing it? What I could have done, put the 3 in before, and so done it from 3 to -2. So let's say that I did that. Well, I'm not going to rush I'm not going to go into too much detail, but well, I can do it all again. But let's say that I put this to an 18 first. So let's say I did this one minus this one. Well, I would get 18, okay, which is the yellow bit. And so in other words, if I switch these around and minus the one from the other one, and did it in a different order, I'd have -18 minus a minus 15 over 3, which would then be a plus 15 over 3. And I would get plus 15 over 3, and I would get positive 33 1/3. Okay, so if I minus one from the other, I always get the same value, but it just in terms of the same absolute value. In other words, if I ignore the negative, the quantity itself is the same. Okay, so what I do then to simply avoid all the issues and to avoid worrying which way around I'm doing it, I simply pop on this, and we'll do it in a different color. Let's do it in green. I simply pop on this. And what this means is the absolute value. So what this means is if I have -3 and I put these on, I'm just making it 3. So the absolute value of 3 is 3, but the absolute value of -3 is also 3. So these two lines say, ignore the negative, just put the value on. And so as soon as I put this on, I can then put the absolute value there and there and saying, okay, whatever I get here, I'm going to just make it the absolute value of. And so the absolute value, so if I put an absolute value sign around this, I then get 33 1/3, which is then the area. Okay, so let me go back. Okay, so absolute value 33 1/3. I'll go back and put it in orange. So the area is 33 1/3 units squared. And so my definite integral between -2 and 3. So this area here that I've marked out is 33 1/3 units squared. And so isn't this fantastic? Because, okay, you can find the area if you have a straight line graph, and then you need to find you can just find the area of the triangle. But this is a weird shape. And of course, I've been able to find the area. How handy. And it works for cubic graphs as well. It doesn't matter how many things. You could have a graph like this, and you could find out this area here and this area. And, you could find the area of, just oddly shaped graphs. As long as you know the function of the graph and you can find the integral, you can find the area. So this is very handy in engineering as well. Okay, so that's the definite integral. So this is just to recap. Differentiation is when you find the slope. The integral is the opposite of differentiation, where you're finding the area of the graph, but the integral is just the equation to begin with that you need to find, which we use this formula, x to the n+1 over the n+1. That's the first step. And then when we find the definite integral, we can actually now look at specific points on the graph that we use between which we can find the area. And then we know that it's possible to get a negative value, which we saw here, -33 1/3, which of course we cannot have a negative area. It doesn't make sense, because if you find the area of a square, it's the area of a square. You can't have the negative of a square, not in this mathematics yet anyway. So we then solve that problem by putting these absolute value signs, saying whatever value I get, simply just change the negative to a positive. Okay, so that's definite integration. Hopefully that helped. And I will see you next time.